On to these carbonyl ones. So we just did the alcohols and the ethers. Now these are carbonyl groups or C double bond O groups. Okay. So we have aldehydes, ketones. We'll talk about carboxylic acids and esters. So they all have a C double bonded O. This is known as a carbonyl group. Okay. So if it's a C double bonded O, that is called a carbonyl group. And we are going to start with aldehydes. Okay, this is when our C double bond O is terminal, meaning it is at the end. So my last carbon, or my first carbon, depending on how you draw it, has a C double bonded O, but instead of having an R on this side, it just has an H. So it's some R group, carbon double bond O with a hydrogen. Okay, this is methanol, carbon with a double bonded O, hydrogen. This is my R group, carbon double bonded O, hydrogen. This is a line one. This is my carbon with a double bonded O and a hydrogen. Okay, the end is Al, so you have to be careful with your alcohols and your aldehydes. The end for an aldehyde is Al. The end for an alcohol was OL. So if it is an aldehyde, meaning it has a terminal C double bond OH, it ends in Al. So this is one carbon, so the prefix is meth, and it ends in, it only has an H over here, so it is an aldehyde, so this is methanol. This one has two carbons, it is ethanol. This has 5 carbons, 1, 2, 3, 4, 5. So this is pentanol, okay, and so on and so forth. Same thing with naming those substituents. You always want to start from the end that is the aldehyde. Now, you do not have to tell me where the C double bond O is, because if it is on an aldehyde, it is on the end. It is on carbon number 1. So this is carbon number 1. So this is pentanol, but I have a substituent here. So this is 2-chloropentanol. Okay, this is butanol, it's 3-methylbutanol. Now, if it is not on the end, okay, it is not terminal, you have a C double bond O somewhere in the middle, it is a ketone. So you do have to tell me where that C double bond O is. Okay, so C double bond O in the middle of R group, so I got an R here and an R here, we name differently. So you do need to number the carbons again, start closest to the C double bond O. If it's same distance between both sides, you want a number from the side that gives you the lowest for substituents. You just want low numbers all around, okay? But you do need to start close to the double bonded O. Okay, you need a number greater than 5 C's for this to matter. Okay, all right, and then the suffix for ketone is unknown. Ketone, unknown. Okay, so this is 3 carbons, carbon, carbon, carbon. This is propanone. Okay, prop for 3, unknown because the carbon is in here. Now, the reason I didn't say where the double bond O is was because, well, it can't be on the other 2 carbons. So it's not an option because then it would be an aldehyde instead. So this is the only option for propanone. Now, if it's like this one down here, though, you have to tell me where the C double bond O is. This is 2-pentanone because the double bond O is on carbon 2. Okay, same thing with 3-methyl-2-butanone. I numbered closest to the double bond O. So this is carbon 1, this is carbon 2. Okay, so the double bond O is the most important thing. The family group is the most important thing. Then you continue your numbering. So I'm going to count closest to here. Over here, I'm going to count closest to here. This is carbon 1, 2, 3. This is 3-hexanol. Now, when you have these benzene groups, we name these kind of funky. I'm not going to have you name these, but this is acetophenone because it's got acetone really, but it's a methyl phenyl ketone. I know that's kind of funky. So instead of saying benzene, because benzene is just this ring by itself, that prefix to say a benzene group is called a phenyl. Okay, so this is diphenyl ketone. So phenyl is the prefix, or is the, alkyl group. That's what you call it for a benzene. Okay, going on. So we did aldehydes on the end, ketones in the middle. Carboxylic acids are when you have a double bond O and an OH. So you have a carbonyl and a hydroxyl. Now this is also always going to be on the end because a carbon that has a double bond O and an OH, that takes up 3 of your bonds. So it can only be attached to 1 other carbon group. Okay, so carboxylic acid is always on the end. So you don't have to give me a number to tell me where it is. And it ends in oic acid, okay, like carboxylic acid. Okay, so many of these are actually really weak acids. They give off their hydrogen on the end, this hydrogen here, or like this hydrogen here, to act like an acid. This carbon is always carbon number 1, just like with our aldehydes, you'd start on the carbon that has that double bond OOH on it. And the suffix is anoic acid. So this has 4 carbons. This is butanoic acid because this carbon has a double bond OOH. Double bond OOH, propanoic acid. 2-methylpentanoic acid because there's a methyl on carbon 2. 3-chloropropanoic acid. This is always carbon 1, so chlorine is on carbon 3. Okay, so you have to figure out which one is more important. The family or the aldehyde, ketone, carboxylic acid is always more important. Okay, so we're going to name each of these. Name each aldehyde, ketone, or carboxylic acid. So you have to identify the group and then you have to identify the name. So if you want to go ahead and try by yourself, go for it. Okay, I am going to talk through these now. So I noticed that I have some groups on here. I've got a chloro and I have a C double bond O. Now it's just a C double bond O and with an H, so it's terminal. So this is an aldehyde. That means it's going to end in Al. Okay, so this is 3-chloro because this is carbon 3. I have to start numbering here. 1, 2, 3, 3-chloropropanyl. This one has a C double bond O, but it has a carbon group on both sides. So this is a ketone. So I have to tell you where that double bond is. So this is 2-pentanone. Okay. And I have a methyl on carbon 3. I start numbering here. 1, 2, 3. 3-methyl, 2-pentanone. Also a ketone. I start numbering over here. 1, 2, 3, 4. 4-bromo, 2-pentanone. This one's carboxylic acid, C double bond OOH on the end. So remember, you don't have to tell me where that is. I don't need like a 1-propanoic acid. I have 1, 2, 3 carbons. There's a chlorine on here, 3-chloropropanoic acid. And I have a cyclo over here. So this would be C double bonded O. This would be a ketone. This has a carbons attached to it, but remember, this is always carbon 1. So you don't have to tell me where carbon 1 is. This is just 3-chloro. Cyclopentanone. Not fun. Okay, and the final like oxygen types of groups that we have is an ester. So this is when you have a C double bond O and an O, but in the middle, right? It's like a carbonyl and an ether. So you have a C double bond O, but it's not an H like a carboxylic acid. It's an R group on both sides. If you have 2 oxygens, this is your ester. Okay, how do we make esters? We do a reaction with a carboxylic acid. So I have an end that has a C double bond OO and an alcohol. So what happens is, and you are going to have to do some of these, I lose the alcohol and the hydrogen on the, whatever this alcohol is, that comes off as a water and they are now attached. So I have if I had a propanoic acid, okay, and an ethanol, right? They would react right here where the carboxylic acid and the alcohol is. I would lose a water and they would become attached. So this is an ester linkage. Okay, I made an ester out of it. Now I have an ethyl over here and an ethyl over here. And I made ethyl propanoate, and you're not going to have to name that specifically one, but this is now an ester. So I make an ester by combining a carboxylic acid and an alcohol. Remove a water, they join, and I now have an ester. Okay, so we're getting a little bit more complicated with the naming then. So the first thing you're going to do is name the alcohol side first with a YL. So this was my ester, right? C double bond OO, there's an R on both sides. So the side where the alcohol came in is one you do with a YL. So on this side, right, this came in, this was my ethanol that came in. So it's ethyl, that's this guy. Okay. Now the side that came in with the carboxylic acid, this was propanoic acid. So you name that side with anoate. So this R group from the carboxylic acid is propanoate. So that's why this is called ethyl, that's this guy, propanoate, that is this side. Okay, so it depends on what it was before you stuck them together. So if I look at this, okay, this is my new ester, right? This is what I made. The alcohol side, this is 2 carbons, that was an ester. And the carboxylic acid side, this was 3 carbons, that was propanoic acid, so ethyl propanoate. I know it's kind of yucky. It's a lot of work in figuring out what's going on, but this is what ethyl propanoate looks like.